Okay, everyone, forgive how horrific this is going to look. But what we're trying to do is a data structure called a linked list. And basically, that's a first in, first out method. FIFO. The way that works is when something enters the list, it kind of gets stacked. Think of like a queue or like a line. When you get in a line at the movie theater to buy your tickets, if you're the first one in there, you're going to be the first one out of there as the line moves forward. Alternatively, the other data structure when it comes to stacks is a first in, last out. That would be like a stack of plates, right? If you put your plate on and then you stack everything on top, and then you have to go down through all the plates before that one leaves again. So the type of linked list we're doing is going to be a first in, first out. What makes it a little bit tricky is dealing with structures. So you have this like container. It's so hard. Ugh. You have this container and it has its own little memory address going on up here. It's also going to contain that data. And that data structure can be anything. As far as this assignment goes, it was like a grocery list. So like produce or fruit or whatever. And so you have your actual data element, which in this case is going to be a type string, but it really could be anything, right? It's just going to be whatever element that you're storing. And then the other part of the structure is actually going to be a pointer. And I think that's where it gets a little tricky because the pointer is going to point to another memory address, right? And the memory address it's going to point to is another little structure. And so that's where it gets a little bit trippy because when you declare a pointer, it needs to have a data type, right? So an integer points to integer types, a string points to string types, blah, 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 blah. Mm-hmm. This is going to be the same type as your struct, which I can't remember what we called it. What do we call our structure? Node. Yeah, so this is going to be of type node. So that means it points to the memory addresses of other nodes. So this, if we had another node, there's its amazing, beautiful address. It's going to be pointing to that address, right? And that's the concept. Of course, the instructions get a little bit confusing, so we're going to walk through the code. But does anyone have any questions with the idea of what we're trying to do here?
So when are the times to use pointers, like in the real world?
In the real world?
Yeah.
It's when you want to do memory management. So when you abstract away and you go towards languages like Python and stuff, we've gotten a little bit lazy in our coding because there's really good libraries and really good languages that kind of handle that for us. But if you want to build really efficient code, pointers will always be the most efficient because you have direct access of pointing towards things. Think of the reference idea that we learned earlier, which is a pointer. If we didn't have references, we would keep making copies of things, which might work, but it's not as clean. If we have access to pointers, we can very cleanly allocate the exact memory we need, point to things we need, things of that nature. So in your like day-to-day life, unless you're working in C++, if you're doing the type of work that Michael does, pointers are super, super, super important. But as you kind of abstract away, they don't become as important. But I will argue they are crucial to understand because even if you don't use pointers every day, to be a good developer, you need to have a very, very good understanding of memory management. Does that make sense? So, I don't know. I know that was kind of roundabout to answer your question, Luis, but best I can do right now. Okay, so that's the idea here. So you create a struct. Within the struct, you have your data element, your pointer, and then every time you make a node, they always just point to the next one. Oh, that's beautiful. I love it. Okay? Okay, perfect. So I'm going to pull up the notes here. I have taken the critique, by the way. I really like this assignment, and there isn't a 1410 teacher at this university that doesn't use this assignment for pointers. And really, I think it is the best. But I think for next semester, I'll try to write my own instructions rather than try to copy and paste these ones. So I do apologize for that. But yeah, we'll just use this. Okay. So we get the idea of it. this graphic is probably a lot better than what I drew. There are a little bit of different little verbiage things that we encounter when we're talking about these data structures. NQ and DQ, it pretty much just means NQ is inserting a new element, DQ is getting rid of that element. Peeking is looking at the next element or sometimes the element in the front. So you will need to get used to that. Okay, UML. I don't think we've gone over UML very much in this class yet. It's going to come up more in the next 2 weeks or so. But right here is going to be your class. In this case is a struct. I know we went over it a little bit, but it's a little bit of review. Here are your private variables. Front, it's of type node pointer. Back, it's of type node pointer. Count, it's an integer, right? And then here we have our functions. And we know that these attributes are private because of the dashes, and we know that these are public because of the pluses. When you get into protected variables, which I very, very briefly mentioned, it's actually going to be that little hashtag or that pound sign. There's probably lots of ways to do it, but that's how we teach it here at Weber. Our constructor, our destructor, this is one of our functions. Notice when a parameter is passed, you have the name of the parameter and then you have the type here. It's always going to be the pattern of name colon type. So name colon type. And then right here is the type of for the function. So it's going to be void, void, string, Boolean. And then this is relationships. I'm not going to get into this today, but this is like a little bit of a schema of how these different classes interact with one another. And so notice with our struct, you just have two attributes, data and next. Okay. Okay, so we'll start here. Actually, we're going to start with creating our struct. That's probably the best. What is this? I don't even know what this is, guys. Exit out of that. Okay. So I have my header. We'll start with doing our struct. Perfect. So we're going to call it node. And remember, according to the UML, we had two data types, or two attributes, I mean. Data, which is of type string. And that's going to house the things like apple, banana, whatever. It's going to be the actual items we're holding. And then we have a node pointer. So this is kind of a trippy concept, right? Because we're creating the struct node, and within that struct, we're referencing itself, right? But this is just a pointer pointing to other nodes. That should be about it on that. Okay. So now we make our class Q. Let's do our private variables. And this is going to be node pointer. It's called front. This is going to be node pointer back int count. So these right here are nodes, so they can hold data members and pointers, but these are very special. They hold a special purpose, and that's keeping track of what's at the beginning of your list and what's at the end of your list. That's really important when you add or take away things in your list. You need to know where you're at. So we're actually not going to be filling temporarily we'll be filling these with data elements, but we're not going to be giving these brand new data elements. These are just kind of like pointing to the front and the back, okay? Public. Let's do our constructor now. So it's public. And the constructor is going to be named like this. So I'm actually going to be giving front and back null pointers at first, right? It's good to kind of instantiate something even if it's null. That's not how we spell that. And I'm actually going to give count to 0. Make sense? Just trying to keep things clean by giving them values. So now we're actually going to give it a destructor. Funnily enough, a destructor actually isn't critical for this assignment because the DQ function actually does the memory cleanup. but it's good. It's good habit and practice because since we're going to be going to the heap and allocating additional memory, it's good to have our destructor. And I'm kind of jumping ahead here, but later we're going to be making a function called isEmpty, and that's just going to see if your linked list is empty or not. So while it's not empty, we're going to call our dequeue method, which is another one we're going to be creating. That's not how we spell that though. DEQUEUE. Yeah, what's up?
I think at least my program was having a problem when I didn't set count to 0.
In here?
Just when you initiate count up there.
Oh, you put equals 0?
Yeah, then it would work, but it wasn't working.
Interesting. Did you happen to put 0 here in your constructor?
I probably did.
Yeah, so that's fine. This is just another way to set it. Either way, it is important that you set it equal to 0, so that's probably why. Okay, so you might have a little bit of a question mark here first, but these are two methods we're going to be doing a little bit later. And like I said, our dequeue method actually should take care of things, but just in case, this kind of ties a bow on it and makes sure that we're deleting our memory. Okay. So now we're going to make the enqueue, I always forget E, enqueue function. The parameter according to the UML is going to be string and data. Let's actually read the instructions here. Okay. The enqueue function is used to add an item to the queue as a first in, first out data structure, which we explained. It adds items to the back of the line. So step 1, define a pointer which points to a new node struct. The new node should be passed in data argument for its data attribute. So set the next data member to null pointer. So if the first thing we need to iron out when we're reading these instructions is everything that it's talking about. So we need to create a pointer and it's to a new node struct. So we're going to be instantiating a node object. The other thing I want to point out is the next data argument. So if you look here, notice that in our struct, we have a next, we have a data and a next. So let's keep that in mind. Okay. And then set the next data member to null pointer temporarily. So what we want to do here is we want to create a new node structure. So what it's referring to is when we create this new node structure, at the time of compile, this new node didn't exist. So we actually have to go into the heap and allocate this memory ourselves. And the kind of the hint in the instructions is when it used the keyword new. All right, so a new node structure. So it's going to be a pointer. I'm going to call it new node. And I'm going to set it equal to new node. Okay? So this, we're declaring a new pointer, and we're actually going into the heap and grabbing memory that's dedicated for that. All right? And then it said we need to make that new node, and we need to point it, the data element within that new node, we need to point it and set it equal to data. Data being this parameter that we're setting, okay? So new node has data and next. We're going to be setting the data portion of it equal to the data portion here in enqueue, okay? Then we're going to be setting the new node next element, attribute I should say, to null pointer. Does that make sense? Michael could probably speak to this better than me, but when we're doing normally when we're dealing with structures, you do this dot, right? New node dot data, new node dot next. Since it's pointers, you actually have to make that little arrow, but it functions essentially the same, where it's new node dot data, right? Okay.
The reason there's an arrow is back in the day, they did dot and notation when they went to actually using pointers. It made coming out of, I don't know, there was a
Gotcha. Cool, thank you. All right. So that should be step 1, right? So step 2, if the queue is empty, then the new node is both the first and the last item in the queue. Set the front and back pointers to the new node pointer. So if the queue is empty, meaning nothing exists, and this new node is the first item that you're inserting into it, it's both the front and the back, right? So these front and back pointers we need to make sure they're both pointing to this first element that we just inserted. It's basically what it's saying. So to do that, we are going to be making an isEmpty function a little bit later. So the easiest way to do that is if you do is, or if is empty, right? If we looked at our UML, we know that isEmpty is going to be a Boolean function, so a yes or a no. So if it is empty, right? If is empty, then front is going to be equal to new node, and back is going to be equal to new node, right? Our front and back private attributes are now both pointing to that element we just inserted. Okay? Otherwise, back next is equal to new node, and back is equal to new node. What's happening here? Anyone want to take a stab? So we're assuming that it's not empty already. So if we look, my beautiful graphic, see if I can erase really quickly. Okay, so let's say this element, this node, already exists, okay? And we're just now inserting a brand new one here. We have a pointer, I'm gonna put F for front, and front points here, and currently, back points here. Now we have this new node coming in here, and it needs to be connected, right? So looking at this, we're saying back next equals new node, and then back equals new node. So since these themselves are nodes, right, they've got their own data and next elements. So back next is pointing here, and then we're erasing this, and we're saying back points here. It's just a way to point the back node to what's actually in the back. So far, so good? Okay. So that should be step 2. Actually, I think that's step 2 and 3. And now step 4 is we just need to increment that count variable. Does anyone want to tell me why you want to increment this? What the count variable does?
It's gonna affect your print later.
Oh yeah, for sure.
It's gonna have another element, so you're adding
Yep.
it. If you don't do that, then
Yep. Yep, it's an integer that just keeps track of how many elements are in your array. It's just an easy way to always have a check so you know how many are there. Okay, so that should be the enqueue. So already we're made good progress there. So now it's the dequeue. So void dequeue, and dequeue is just it's just going to be deleting things from the array, or the list, I should say. All right, we did steps 1 and 2. We did 3. Here's another really good graphic. Notice how each node, and this would be the next. Next is pointing to the next one. Next is pointing to the next one. And then you have back, and then next is pointing here, and then back would be pointing there, right? Okay. And then increase the count variable 1. Okay, it's going to be void. The dequeue function is used to remove an item from the queue. It's also first in, first out data structure. Elements removed from the front of the line. Okay. So step 1, if the queue is not empty, we need to do the following. Store the current front pointer into a temporary pointer variable. This is necessary to retain access from after the front pointer is changed. So when we did that reverse array try it out assignment last week, last week, remember when you're swapping variables around, you need to kind of have a third temporary variable. This is the same concept here. This is necessary to retain access after the front pointer is changed. So then we need to set the front pointer to the next pointer of the current front pointer. You can see how this is a tongue twister to read. Then we need to delete the temporary variable and decrease the count variable by 1. So the first part is we need to store the current front pointer into a temporary. So to create that temporary, we need to make a new node pointer, and I'm just going to call it temp, and I'm going to set it equal to front. Okay? So if we go back here, let's just say we got something like this, right? So what I just did is I created a new node and I called it temp and I set it equal to front. So I'm going to put T for temp. It's a brand new node and I'm actually setting it equal to this. Okay, so these are essentially the same thing. Okay, next step. Front is now going to be equal to front next, right? So now what we're doing is this, this is next, right? Ugh. Oh, so awful. Oh, I love it. So front is now going to be equal to front next. So now it's going to go here and point, right? So I'm going to erase that. Right, so here it went over there. Then we need to, front equals front next. Then we need to delete temp. And remember, to delete memory, we just use that delete keyword, right? Delete temp, and then we need to get rid of the count. So I called it temp. If it is empty, then we're just setting back equal to null pointer. All right. And oh, I forgot something. I forgot the if it's not empty part. I apologize. If it's not empty is when we're doing all of this. So I could actually just do an else. Like that. I'll just do else. And this can go away. Okay. Make sense? Not empty, do this. Otherwise, set back equal to null pointer. So, make sense? And since we deleted this, it deletes this. So now front is just pointing here. Okay. Okay, so that's good with the DQ. So now we want to do peak. Peak shouldn't be too hard. It's a type string according to the UML. Basically, if the queue isn't empty, we want to return the data of the front element. All right. So if not is empty, if it's not empty, then I'm just going to do return. Return front data. Else return an empty string. And that's all peak is. Okay. So now we actually are going to make the isEmpty function. It's going to be Boolean isEmpty, no parameters. If front is equal to null pointer, then return true. Else return false. All right, real simple. Okay, we have another one. Type int, it's called size, no parameters, and all we're doing here is returning the count. Because count is private, remember? So if we want to directly access that, we're going to have to use a function. Okay, now we're making print, void, print, no parameters. Oh my goodness, guys. If isEmpty, then we're just going to see out the queue is empty. Else. Okay. If it's not empty, what we're going to do is we have to create a new node. We're calling it temp. We're actually going to set it equal to front. And then while temp is not equal to null pointer, we're going to see out temp.data. Give it a little space. And then we have to set temp equal to temp next. This makes sense? This is just, next. This is just how we're going to iterate through each element. We're just going to create a new node, and we're just going to go through each one and point to each node and return that data before going to the next one. And then we're going to, for formatting reasons, we're going to do that. I think that might be it. Let's check. Oh, looks like we still have errors. Oh, no, we don't. All coding should be done in the header. So I think we're good. Let's walk through this main and make sure we kind of understand what's happening. So I'm declaring my queue object. I'm first going to print what's in there. It should be empty. I'm then going to pass in an apple. I'm going to look at the size. I'm going to print. We're going to delete that apple. Now we're going to try to delete that apple again, or try to dequeue an item again. And since it's empty, we need to make sure we have it coded so it doesn't just crash on you. Then we're going to peek and see. Remember, this is still an empty queue. So we're going to peek. Hopefully it won't crash on us when we try to peek. And then we're going to add a couple things. Check the size, print them, remove one at a time. We're going to add an additional thing, and then peek again. Okay? There you go. Queue is empty. Item. Queue is empty. 3, 2, 3. Perfect. Let's try to and passed all tests. We good on that, guys? Make sense? Okay. You are all great.